Ma'am, you can start now.
Hi, good morning, students. I'm Sushila Ghuge from Dr. Ambedkar School, and you all welcome in our science online session. Okay, students, before starting our new lesson, I want to show you something. Do you want to see something? See?
Yes, miss.
Yes, okay. Wait, I will show you something. Oh, see, my all pins fall down. Now I have to collect all these pins. But
Yes.
it time now.
Yes,
Then
miss.
to one idea. Okay. See. Oh, it's magic. Yes.
No.
Magic?
No.
No. Then what is this?
Magnet.
Yes.
Magnetic power.
Yes, this is magnetic power and this is magnet. See?
Yes.
Connected all the pins. Yes.
Yes.
What is this?
Magnet.
Yes, this is magnet. Yes. And I think you all played with magnet.
Yes. Yes.
It likes magic, na? And
Yes. Yes.
I also like to play with magnet. Do you want to see more magnets? I have so many magnets. Beta,
Yes.
take. See, I have these two magnets. These are bar magnet. Okay.
Yes.
This is one U-shaped magnet. This is called horseshoe magnet.
Which magnet? Horseshoe magnet. Horseshoe magnet.
Yes.
Horseshoe magnet.
I also have these two magnets. That these magnets. Okay.
Which magnet, miss?
This beta. This magnet. Okay. And one more. This is compass. What is
Yes.
this? Compass.
Compass.
And it is used for navigation.
Yes.
Yeah,
Direction.
compass also magnet is used. Okay. So these are all our types of magnet.
Okay.
And now we'll do some interesting activity with magnet.
Okay.
Yes. Do you want to see that activity?
Yes. Miss.
Yes. Okay. Wait a minute. See, first, you should know that this is north pole of magnet. See, N is written here now. This is
Yes.
north pole, and this is south pole.
Yes.
And
Yes.
when we hang this magnet like this, it always settle in the north-south direction.
Yes.
Yes, when we hang this magnet freely, it always settle in the north-south direction. Okay. Now I will show you one interesting activity. See, these are two bar magnets. Okay. This is south pole of magnet. And this is also south pole. See, this is another bar magnet. And this is a south pole of this magnet. See, I will show you one magic. So what happened? This magnet repels to this magnet, na? Yes, see?
Yes, miss.
Yes. One more magic. This is south pole and this is
Yes.
pole of this magnet. Now see what will happen. Then I take this magnet near to this magnet. What happened?
NS, north, south.
Yes, north, south. But what happened? They attract, na?
Yes.
Yes.
They attracted each other to each
Yes.
other. And if I take two similar pole near to each other, then they repel. See, this is north pole. This is also north pole. See what happened. They are repelling.
नॉर्थ नहीं चिपकेगा, साउथ भी नहीं चिपकेगा।
Yes,
नॉर्थ और साउथ चिपकेगा,
Yes.
साउथ
only south to north.
means what is this? Like poles repel each other and
Yeah.
like poles attract to each other.
Yes.
Yes.
Characteristic of magnet. Now one more, huh? One
Yes,
more.
miss.
Okay. See, these are iron fillings. What is it?
Iron.
Means
Really.
small ions. Okay. Now
Yes.
see. Now see what is this? What you observe here?
He attract the iron.
Yes, this magnet attracts iron fillings. But
Yes.
here, but here, this magnet attracts these iron fillings to the poles
Both.
only. So from this we can say that now there is maximum magnetism is to the these poles only. Yes?
Yes.
Yes. Yes, we can say that. Okay. Now we will start our lesson. Okay.
Okay.
Wait a minute. I will share my screen.
Okay.
So I welcome you all in our online session, and our next lesson is properties of a magnetic field. This is lesson number 19. That is properties of a magnetic field. Okay. So what is magnet? A magnet is a rock or a piece of metal that can pull certain kinds of metal towards itself. Magnet is a rock or metal, and magnet attracts some kind of metals towards itself. Magnet not attracted all the substances. Now we will see which are magnetic substances and which are non-magnetic substances. See, substances which are attracted by magnets are called magnetic substances. Here are some examples of magnetic substances. Iron, nickel, tin, steel, cobalt. These are magnetic substances because these substances are attracted by magnet. Okay. Next one is non-magnetic substances. Substances which are not attracted by magnets are called non-magnetic substances. See, wood, plastic, paper, glass, copper, brass, rubber. These are non-magnetic substances. These substances are not attracted by magnet. Now, types of magnet. I have shown you some magnets. Okay. And here in picture, you can see different shapes and sizes of magnet. These are the different shapes and sizes of magnet. And these magnets are used in our daily life. Okay. What you can see in this picture, these things we used in our daily life, na? Fan, disk, telephone, computer, all these things we used in our daily life. And in all these things, magnet used.
Yes.
Yes, in all things, magnet is used. Okay. Now we will
Yes.
see where and how are magnets used in our houses and our surroundings. See, first one. Magnet is used in pin holder, doorbell, doors of a fridge and cupboard. It is used in pin holder. Our doorbells also working with the help of magnets. Second, an electromagnet is used in big crane to lift heavy load. Third, the modern medical technique such as MRI means magnetic resonance imaging, also uses magnetism. Next, a magnetic strip is used in ATM cards, credit cards, and debit cards. If you've seen ATM cards, there is magnetic strip is there. Next, hard disk of computer, audio and video tape, etc. also use magnetic materials. Next, a magnet is used in maglev train and magnetic separator. Next, it is also used in microphone, electric motor, and electric generator. These are the uses of magnet in our day-to-day life. Okay, in daily life, magnet is very useful for us. Now, which metals are used for making magnets? See, these are the metals: cobalt, nickel, iron. From these metals, magnets are made. Nippermac, an alloy of iron, nickel, aluminum, and titanium. This is one type of magnet, Nippermac. Alnico, this is also one type of magnet. Alnico is magnetic alloy of aluminum, nickel, and cobalt. So remember this. Magnets are made from alloys of iron, nickel, and cobalt. Now, we will see some characteristics of magnet. Okay? See, in which direction does a freely suspended magnet settle? If we suspend a magnet freely, like this, you can see in this picture. If we suspend magnet like this, the freely suspended magnet always points in north-south direction. If we suspend this freely, it always settles in the north-south direction like this. This is north direction and this is north pole of magnet. So it always settles in the north-south direction. Next characteristic. What are the names given to the two ends of the magnet? And why are they named thus? These are two poles of magnet. This is north pole. This is south pole. North and south pole. So these are the names of magnet, poles of the magnet. North pole and south pole. These are the names given to the two ends of magnet. See, why are they named thus? उनको वैसा नाम क्यों दिया है? Because the end of a magnet that points to the north of the earth is called the north pole of the magnet. This north pole points to the north of earth. So it is called north pole of magnet. And this is south pole. The end of a magnet that points to the south of the earth is called the south pole of the magnet. These south poles points to the south of the earth and it is called south pole of magnet. Now see, if we break magnet in many pieces, then also the poles of a magnet cannot be separated and always exist in pairs. Means, suppose here is one bar magnet, this is N and this is S. And if we break this magnet into two pieces, then also two magnets form, two poles form. This is north pole, this is south pole. This is north pole and this is south pole. These poles cannot be separated. This is a characteristic of magnet. Next one. The attracting power of magnet is maximum at the two ends and minimum at the middle. In our activity, we saw this. Okay. In that activity, we saw that the iron fillings stick to the two ends maximum. Two ends because they have maximum power of attracting. Okay. So the attracting power of magnet is maximum at the two ends and it is minimum. In our activity, we saw that the iron fillings not attracted in this portion. Now next one, like poles repel and unlike poles attract. See, when the north pole of magnet brought close to the north pole of another suspended magnet, the two magnets repel each other. In our activity, we saw this also. Then we keep two similar poles to each other. They repels. And when south pole of magnet is brought close to the north pole of another suspended magnet, they attract each other. Here is attraction. These are unlike poles. This is south pole, this is north pole. They attract each other. And here is repulsion. This is south pole, this is south pole. These like poles repel each other. So we will summarize all these characteristics of magnet. So first characteristic, we saw that a magnet always settles in the north-south direction. Second, the magnetic force is concentrated at the two ends or poles of a magnet. Third, if a magnet is divided into two parts, two independent magnets are formed. It means that the two poles of a magnet cannot be separated from each other. Okay. Next, a magnetic material acquires magnetism when placed near a magnet. This magnetism is called induced magnetism. Next, there is repulsion between like poles of a magnet while there is attraction between the opposite poles. These are the characteristics of magnet. Now, we will see what is magnetism. See, magnetization is the property by which a magnetic substance attains magnetism temporarily or permanently. We will see two methods of magnetization. First is single touch method of magnetization. This is single touch method and this is one activity. For this activity, you need one steel bar and a bar magnet. For this activity, suppose this is steel bar AB. This is A point, this is B point, and this is steel bar AB. So after that, take a bar magnet and place its end pole on the A end of the steel bar and drag it towards the B end. You have to take one bar magnet and its end you have to put here and drag it towards the B end like this. Again, lift the bar magnet and drag its end pole from the end A to the end B. And you have to repeat this for 15 to 20 times. Lift this bar magnet from here. Again, drag this like this. Drag this bar magnet from point A to point B like this again and again for 15 to 20 times. Now, after doing this, take the steel bar near the some iron fillings and observe what happens. If you observe now what happens, then the steel bar will be seen to have developed magnetism. If we do like this now, this steel bar develop magnetism. And this method of magnetization is called the single touch method. This is single touch method. What we do in single touch method? We take a steel bar AB, then n pole of bar magnets placed here, then it is dragged like this for 15 to 20 times again and again. So the steel bar will be seen to have developed magnetism. इसमें क्या आ जाता है, जो स्टील बार है उसमें मैग्नेटिज्म आ जाता है, but this is temporary. The magnetism generated by this method is of low strength and lasts for short time. After some time, the magnetism disappears. Okay, this is called single touch method of magnetism, and the magnetism generated by this method is of low strength and it lasts for very short time. Now, second method of magnetization, that is double touch method of magnetization. In this method, we have to use two bar magnets. See, here is again one steel bar, that is A and B. This is steel bar AB. But here we have to take two bar magnets and place two opposite poles of the two bar magnets at the center of the steel bar. Here is center of steel bar. These are two bar magnets. But you have to take two opposite poles of bar magnet and drag these poles apart, one to the A end and other to the B end, like this. This bar magnet you have to drag like this, and this one like this in opposite direction. Okay, and you repeat this also for 15 to 20 times. Now see, observe what will happen. If you take this bar magnet near to iron fillings, that iron fillings attracted towards this bar magnet. So this method of magnetization is called the double touch method. This is double touch method of magnetization. Here we use two bar magnets, and the magnetism generated by this method lasts longer compared to that generated by the single touch method. From this method, the magnetization generated is lasts for longer time. So these are the two methods of magnetization. First one is single touch method and second one is double touch method. In single touch method, the magnetism created by is of low strength, and in double touch method, the magnetism generated lasts for longer time. Now next point is, do you know the earth is one massive magnet? Our earth is like one massive magnet. Massive means a very great or huge, big size magnet. Our earth is. Now we'll see how. Because the earth's core is a mix of iron and nickel, and it gives the earth its very own magnetic field. In earth's core, iron and nickel are present, and that's why earth have its own magnetic field. Now, why does a freely suspended magnet always settle in the north-south direction? It is because of this Earth's magnetism. Earth is a huge magnet, and because of this, the freely suspended magnet always settle in the north-south direction. And this is proved by scientist William Gilbert. The scientist William Gilbert give a scientific explanation based on experiment of the observation that a freely suspended magnet always settle in the north-south direction only. He gave a round shape to a naturally occurring magnetic rock. Then he suspended this spherical magnet so that it could run off freely and brought the north pole of a bar magnet near it. The south pole of the magnetic sphere was attracted towards it. See, the freely suspended magnet always settle in north-south direction, and this is proved by observation. For this, one scientist is there, William Gilbert. He gave a round shape to a naturally occurring magnetic rock, and he suspended that rock, and after that, he brought a north pole of bar magnet near to it. Then what happened? The south pole of magnetic sphere was attracted by north pole of bar magnet. From this, it is proved that the freely suspended magnet always settle in the north-south direction. Now you know that. Which magnetic poles attract each other? Which magnetic poles attract each other?
North
Opposite.
pole and south pole attract
Yes.
each other.
North and south pole means,
South pole attract.
yes, means they are opposite poles.
Yes.
Okay. So opposite poles attract each other. And in this experiment, in this Gilbert's experiment, which pole of spherical magnet will get attracted towards the south pole of bar magnet?
North pole of a spherical magnet will get
North
attracted towards the
Yes.
south pole of the bar magnet.
Yes. The north pole of spherical magnet will get attracted towards the south pole of bar
Bar
magnet.
magnet
Because opposite poles attract each other.
attract each other.
Yes. See, this is geographic north pole of Earth. And here, geographic south pole of Earth. Here is north pole, here is south pole. And the north pole of freely suspended magnet settles in the direction of the geographic north pole of Earth. So, it means a south pole of some gigantic magnet must be near the geographic north pole of Earth. And see, the south pole of this magnet must be near the geographic north pole of Earth, while the magnetic north pole is near the geographic south pole. Here is geographic north pole, here is geographic south pole. And this is south pole of Earth's magnet. It is in the north. So this is north and south attract. This is geographic south pole of Earth. This north and south attracts. And from this, Gilbert proves that the suspended magnet always settle in the north-south direction. Okay. Have you understood these points? Characteristics of magnet,
Yes, miss.
the names given to the two ends of magnet,
Yes, miss.
which metals used for making magnets,
Yes, miss.
types of magnetism. Okay.
Yes.
And Earth is a massive magnet, a huge magnet. So we will do some revision.
Yes.
Okay. I
Yes.
will ask you some questions. If you know, unmute and give answer.
Yes. Yes.
See, question 1.
Yes, miss.
Only one will give answer. Okay. Now see question 1. Which metals are used for making magnets? Which metals are used for making magnets?
Iron, cobalt, nickel, aluminium.
Aluminum. Titanium.
Iron, cobalt and nickel. Iron, cobalt and nickel
Yes.
are used for making magnets. Okay.
Yes.
Now second question. In which direction does a freely suspended magnet settle? If we settle a magnet freely, then in which direction it settles?
North Pole.
North
Pole direct.
Pole.
Direction, tell me direction.
North
North
Pole
Pole.
and South Pole.
North-south direction. It is called north-south direction. Okay? So,
Okay, miss.
a freely suspended magnet settle in north-south direction. Understood?
Yes.
Now, next question. What are the characteristics of magnet? Tell me some characteristics of magnet. Characteristics of magnet.
South Pole.
Sorry.
North to North. In clock.
It is suspended magnet always settle in north-south direction. This is one characteristic. Okay.
Yes.
Second one.
Divertive property. A freely suspended magnet settle.
Yes. Freely suspended magnet settle in north-south direction.
Yes.
This is one characteristic. And one more. Like poles and unlike poles. Do you know that characteristic, na?
Yes.
What will happen to like poles?
North Pole, North Pole.
Like matlab same poles.
Repel and
Yes.
poles attract.
Yes, very good. Like means same poles repels to each other. And unlike means different poles attract to each other. And next one. Next characteristic. Magnetic power is maximum at two ends. We saw this, na?
Yes.
Magnetic power. Yes, magnetic power is maximum at two ends of magnet. We saw that in activity also. Okay.
Yes.
Now next one.
Magnet
Next question.
to only some metals.
Yes, very good. It is also one property. Magnet only attracts some metals. Okay. Now next question. The end of a magnet that points to the north of the earth is called the dash dash of the magnet.
South of the earth.
Yes.
South of the earth.
What we call that? That
South Pole.
Yes, very good. North Pole. The end of a magnet that points to the north of the earth is called the north pole of the magnet. Okay. So what will come here? North Pole. Yes, we can. You can write differentiate also. Okay. Now next question. Next question. The end of a magnet that points to the south of the earth is called the dash dash of the magnet.
South pole of the magnet.
Yes, very good.
Pole of the magnet.
Yes, it is called
South pole of the
south pole
magnet.
of the magnet.
Magnet.
Okay. And tell me two methods of magnetization.
Two methods of
Magnetization. Which two methods we studied?
single touch method, double touch method.
Yes, very good. Single touch
Double touch
double
method.
touch method. These two methods we have studied. Okay. And the
Yes.
magnetism created by single touch method is of low strength.
Low stretch
Yes.
and last for a short time.
Yes. And the magnetism generated by double touch method is last longer.
Longer.
Okay. And one more point we studied that huge magnet. Yes, it is a huge magnet. So today we studied all these points. Remaining points from this lesson we will see tomorrow. Okay? So see you tomorrow.
Yes.